My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 151. In this lecture, we will try to understand critical value approach to two-tailed hypothesis testing. I will consider same problem which we discussed in our previous lecture. Before discussing the problem, just let me say a few words. The critical value will occur in both lower and upper tails. That is important. You can find critical value in lower tail as well as in upper tail, isn't it? Yes. I will repeat, the critical value will occur in both the lower and upper tails of the standard normal curve. Use the standard normal probability distribution table to find Z alpha by 2, the Z value with the area of, here I need Z alpha by 2, I need Z value with the area of alpha by 2. This is Z value with area of alpha by 2, isn't it? In the upper and lower limits, anyway we will try to understand. We already discussed in previous lectures, there is some function norm.ppf. This function is useful to find Z value corresponding to area, isn't it? It is opposite of this particular function norm.cdf. Just I request you to go through those lectures so that you can easily understand. Before solving this problem, first we will try to understand the parameters. What are the parameters here? Assume that sample of 30. What does it mean? Its sample size. What is the size of the sample? N equal to 30. Isn't it? Sample of 30 milk carton provides a sample mean of 505 ml. What is a sample mean? Sample mean is x bar. That x bar is 505. That is my x bar, isn't it? Yes, sample mean of 505 ml. The population standard deviation, that is sigma. What is my sigma value? Population standard deviation 10 ml. Perform hypothesis test at 0.03 level of significance. My alpha value is 0.03 level of significance. Population mean 500 ml. Therefore, mu equal to 500 ml. And help to determine whether the filling process, this I already discussed. Just I have to calculate Z statistic. How can I calculate that Z statistic? Z equal to x bar minus mu by sigma by root n. We already identified variable which are used. X bar is 505. Just see 505 I substituted. Mu is, what is mu? Mu is 500 I substituted. And sigma is 10. I substituted sigma equal to 10. And n equal to 30. This n equal to 30. Now we have got, what is our Z value? Z value is 2.74. We will try to make use that Z value. Before solving that problem, let me go back and write the steps. First, I must write null hypothesis and alternative hypothesis. I already discussed about null hypothesis. It is status quo. What is my null hypothesis? Just refer my previous lecture in which we were saying that same problem. As we are solving same problem, your null hypothesis H0 is mu equal to 100. What about our alternative hypothesis? Mu is not equal, mu equal to 500, and mu1 is not equal to h1 is mu not equal to 500, and it is two-tailed test, isn't it? What is our level of significance? In question itself it's given alpha equal to 0.03. It's given in question, isn't it? How can I calculate? Compute the value of statistic. We already calculated. I think we have got, it's 2.74, isn't it? Now what I have to do, I must calculate critical values the critical values will occur in both lower and upper tails. Why? Because it is two-tailed test. It will occur in both the tails. Use the standard normal probability distribution to find Z alpha by 2. We will find what is that Z alpha by 2. We know what is Z alpha by 2. How can I calculate Z alpha by 2? In question itself, in alpha is given. What is our alpha value? 0.03. Now I can find Z alpha by 2, isn't it? After calculate, how can I find Z alpha by 2? With the help of norm.ppf. This function I already discussed. Now we have got Z alpha by 2 and we already calculated Z value. Where in initial slide only I calculated Z value by using x bar minus mu by sigma by root n. With that means I have Z value as well as Z alpha by 2 value. Reject Z naught. If Z means my calculated value, this one test statistic is less than or equal to minus Z alpha by 2. Means if it is left side of minus Z alpha by 2 or if it is right side of Z alpha by 2, I must reject. When can I reject? If it is not in acceptance region, means either it must be less than or equal to Z alpha by 2 or it must be your calculated value must be greater than or equal to Z alpha by 2. We will try to understand, determine the critical value. What is my alpha value? In question itself, alpha value given 0.03. How will I get alpha by 2? 0.03 by 2 means 0.015. Now I need Z alpha by 2 value. The alpha by 2 is essentially 0.015. Therefore, I must calculate Z value corresponding to this particular value. How can I calculate? We know that. Anyway, I will explain how to calculate. Time being, just understand our value is 2.17. It is simple and straightforward. We will see it. First, let me, this is my Python code. Just go to this Jupyter notebook, execute this one. Stats.norm.ppf. Stats. What is that alpha by 2? Alpha by 2 is 0.015. 0.015 means what? What will you get? You will get on left hand side, isn't it? Just see this one. 0.0. This entire area, left side of this 0 is area is 0.5. 0.051 means this one. What is corresponding value? That is 2. That PPF is opposite to CDF, isn't it? For 0.015 area, what is my corresponding Z value? This is minus 2.17. As it is symmetric, I can find if it is 0.015 area, if it is minus 2.17, this must be plus 2.17. What is our calculated value? 2.74. This is my acceptance region, this white region. But what is my rejection? This region is rejection region. Where is my 2.74? It is right side of 2.17. Therefore, it is in the critical region. Therefore, your Z value is in the critical region. If it is right side of 2.17, I must reject. Even if it is left side of minus 2.17, in that case also I must reject. This 2.74 is right side of 2.17. Therefore, I must reject null hypothesis. If it falls in between minus 2.17 plus 2.17, I can say do not reject H naught. But here your Z value, that is 2.74, is right hand side of 2.17. That is Z value corresponding to alpha by 2. Therefore, as it is in critical region, we must reject H naught, isn't it? Reject H naught. This is the rule. If it is left side of minus 2.17 or right side of 2.17. Here our value is 2.74. My calculated value is 2.74. As it is 2.74, which is greater than 2.17, it's right side of 2.17. Therefore, what I have to do? I must reject H naught, isn't it? The test statistic 2.74 is lying on the right side, on the rejection side, isn't it? Therefore, reject H naught. Assembly process is not, I can say this H naught is correct. Simply I can say there is sufficient statistical evidence to infer that null hypothesis is not true. You are not accepting, you are rejecting. What does it mean? You are reject H naught. Why? Because your calculated value is in critical region. So we have to accept rejecting H naught. Therefore, I must accept H1. Accept H1. H1 means what? Alternative hypothesis. That means assembly process is not filling average value of 500 ml. We have to stop that assembly line, make corrective action. That's conclusion. It is simple problem, simple procedure. Just I calculate Z alpha by 2 value with the help of your PPF function. Calculate Z statistic by using x bar minus mu by sigma by root n. Just apply this test. If that calculated value is less than minus Z alpha, or that calculated value is greater than Z alpha by 2, less than Z alpha minus Z alpha by 2, or it is greater than Z alpha plus Z alpha by 2, I can say that will be in rejection region. If it is in between, and that I can say it will be accepted. But here, as your 2.74 is greater than 2.17, it is right side, it is in critical region. Therefore, I must reject. Means I can say null hypothesis is not true. Just go through this lecture once. Certainly one can understand. If you have any difficulty, please keep a comment. Thank you very much.